Hi guys, in this video we are going to discuss about AC circuit with RL based on syllabus of Vishwesvaraya Technological University, Belagavi, Karnataka. Let us begin AC circuit with RL by considering pure resistor R and pure inductor L. Both are connected in series and the series combination is connected across alternating voltage source V is equal to Vm sine omega t. Here the alternating current I flows through in this closed path. Due to this flow of the current, we will get that the voltage drop across resistor, that is Vr, and already we know that the imaginary resistance of this inductor is indicated by XL, where XL is called reactance of inductance. Its unit is ohm. So this is almost equivalent to resistance. Okay. So due to this resistance of this inductance, that is called reactance. So due to this reactance, we'll get that the voltage drop across inductor, let us say that is a VL. As per the previous videos, we know that the phasor relation between current and voltage across resistor is like this. So in that case, we consider the voltage as a reference and this current I, that is the current flow through this resistor, both are in same phase. In case of pure inductor, the VL is the reference, that is the voltage is considered as a reference, then current is lags by 90 degree. The current is lags by 90 degree or pi by 2 radians. So based on this, we will draw the phasor diagram for this RL circuit. For this, I would like to consider complex plane. The x-axis indicate that the real number and this y-axis indicate that imaginary number is indicated by J. Okay. So here in this case the resistance and inductance both are in series, so therefore current flowing through this component is same, so therefore I want to consider I as a reference. The reason is why I is considered as a reference is because current is common, the voltage is different. Okay, let us say from this phasor diagram what you can say that both are in same phase, so therefore the voltage drop across the resistors and the current both are in same phase. And here in the second diagram the VL is considered as a reference, therefore current is lags. If the current is the reference, then the voltage is leads by 90 degree or pi by 2 radians. So therefore let us draw VL which leads by 90 degree because current is the reference. The resultant of these two, what will get that the applied voltage V. Okay, here this VR and VL are the complex number. So VR is indicate that real number and VL is indicate that imaginary number. So therefore the applied voltage V is equal to VR plus JVL. We know that VR is nothing but the voltage drop across resistor and the VL is nothing but the voltage drop across inductor. So I is common, take it outside, then it is V by I is equal to R plus JXL, where V by I is nothing but impedance, that is equal to R plus JXL, where Z is called impedance, its unit is ohm. Okay, let us calculate the phase difference between the voltage, applied voltage and current in the circuit. Let us call this as a pi, where pi is equal to tan inverse of XL divided by R, where Z is the complex number, so therefore let us consider its magnitude. Mod Z is equal to square root of R square plus XL square. Okay, so Z is equal to R plus JXL. Z is equal to R plus JXL is Cartesian form. are rectangular form, then mod z at an angle of pi is the polar form. This is rectangular form. Okay. Now let us consider voltage as a reference in this case. If voltage as reference, say that if voltage is a reference, then the current is lags by pi degree. So we'll consider the same thing as equation. Then I is equal to v by z, z as a complex number. Then its polar form is, as we know, that z angle of pi. Then this is equal to v by z at an angle of minus pi, where minus sign is indicate that the current is lags by pi degree. So therefore the current equation is here, I is equal to v divided by z sine omega t minus pi, or I is equal to Im sine omega t minus pi. So from this, what you can say, in case of RL circuit, current is lags voltage by pi degree. Okay, this is all about the phasor relation between voltage and current in case of pure resistor and inductor circuit. Okay, so well, now we'll calculate average power in RL series circuit. As you know that P is nothing but it is a product of voltage and current, where V is Vm sine omega t and I is nothing but Im sine omega t minus pi. Okay, this is equal to Vm Im sine omega t into sine omega t minus pi. As you know that from the trigonometric formula, that is product formula, sine A into sine B is equal to 1 by 2 cos A minus B minus cos A plus B, this whole bracket. Okay, so let us say this is A and this entire term is B. So therefore the above equation is Vm Im divided by 2 cos A is nothing but omega t minus the B term in this whole term, that is minus omega t minus into minus plus pi minus cos omega t plus omega t minus pi. This is equal to Vm Im by 2 into plus omega t minus omega t get cancelled, cos pi minus cos 2 omega t minus pi. Okay, here the average power basically consists of two parts. This is first part, let me say, this is second part. As you know that we are calculating average power and the power is always scalar quantity. The power is scalar quantity. So therefore we will consider average value itself. If even though I consider the half wave, its frequency is almost double than the supply frequency, So therefore its value is going to be 0 for half wave. Hence the secondary part of this power is going to be 0. So therefore P is equal to, we'll get that Vm Im divided by 2 into cos pi. This is equal to, let me write this equation as Vm by root 2 and Im by root 2 into cos pi, where Vm by root 2, Im by root 2 is RMS value. So capital V and capital I both are represents RMS value into cos pi. So the power consumed by pure resistor and inductor is Vi cos pi. Okay, let us represent voltage, current, this power in as a waveform. Okay, let us consider this is omega t along the x-axis. Along the y-axis, first we'll consider V, then this is V. Okay, fine. And current, already we know that the current is lags by pi degree. So therefore let us say this current is lags by pi degree. I want to draw the current by broken line. Okay, so this is solid line is voltage, that is Vm sine omega t, and the broken line is current I. Then let us extend this up to reference axis. Then the power is the product of these two. Between 0 and the pi instant, voltage is positive and current is negative. So therefore the product of these two will get that negative power law. And between pi and the pi, so in this two instant, voltage is positive and current is positive. So therefore the product of these two is, we get power as positive. Between this pi and the next instant, that is a pi by pi, again here the voltage is negative, current is positive. So therefore this is the power law. And pi by pi to 2 pi, in these two instant, what we can say, current is negative, voltage is negative, again power is positive. Okay, from this one is clearly indicate that the area of negative lobe is smaller than the positive lobes. So therefore what we can say, the pure RL series circuit consumes power, that is a P is equal to Vi cos pi. Well,